Alright, ladies and gentlemen, welcome back. What we're going to be discussing today is how to graph a quadratic equation, or a quadratic function, I should say, when it's not written in standard form, or when it's written in standard form and you have to convert it into vertex form. Now remember, here's what we have in standard form: ax squared plus bx plus c. Well, in vertex form, hello, marker, where are you? Oh no, what did I do? So here in vertex form, it should look like a times x minus h squared plus k. And that's what we want it to look like, because that's how we can identify what the transformations are, so we can graph it just, with our own self-knowledge without having to rely on a calculator. Now here, let me just explain what this is saying. Here, if they're saying a is greater than 0, this is going back to our in behavior. That's basically saying, well, we're going to have a parabola that where both the left and the right side go up. If it says a is less than 0, that means that a is a negative number, so it's reflected over the x-axis, so the left and the right sides go down forever. That's what they're just kind of referring to when we're talking about in behavior. So here, again, pay attention to what the vertex is. The vertex comes from the h and the k value, but keep in mind, here h is positive, here h is a negative. So basically, whatever's inside of the parenthesis, when we write the vertex form or when we write the vertex as a set of ordered pairs, we're always going to take the opposite of where the h value is, but the k value stays exactly the same, whatever we happen to have. And that's pretty much what we're going to be doing, is taking a standard form of a quadratic function and putting it in the vertex form, so that way we can identify what are the transformations so that we can graph it. Now, here, make sure you take the time to actually pause the video if you need to and get this stuff written down. Because these are the steps. It's just an algorithm. It's just a process of how we're going to be converting these quadratic functions from standard form to vertex form. First thing that we're going to do is factor out the a value, whatever it happens to be, from just the first two terms, not the third term. Okay? Then off to the side, what we're going to do is take whatever that middle term wound up being, whatever that b term was, we're going to divide it by 2 and then square it. Whatever that value is, that goes into like our new c term of what we're going to be doing when we create a new quadratic form, or a new quadratic expression as we do our conversion. And you'll see what that means here shortly. What we're also going to do at the same time is take whatever the a value was, and we're going to subtract that to the overall problem, and it's also going to be multiplied to that new number that we figure out. Again, it's going to make sense here in just a little bit. But again, make sure, I'm just trying to explain it briefly what we're going to be doing, because you're going to go through this several times throughout this lesson. And so at that point here, this is just a quadratic formula. If we want to find out what the solutions are, it's no big deal. We're not really going to do anything with the quadratic formula here. Again, this is just a review over the discriminants, meaning that, remember, for every quadratic equation, no matter what, we always have two solutions. Here, if the discriminant is greater than 0, we have two distinct numbers, meaning it crosses the x-axis clearly at two different places, once and twice. Here, if the discriminant is equal to 0, well, that means it's going to touch the x-axis at one place. And if the discriminant is less than 0, that means we have an imaginary solution, meaning it doesn't touch the x-axis at all. So now let's get into our first example. So f of x is equal to 3x squared minus 6x plus 4. Now we could easily type that into a graphing calculator if we were going to be able to use them and see what we needed to see on here, but we don't have a graphing calculator, so let's go ahead and convert it into a vertex form of a quadratic, and that way we can just look at the transformations and graph it from there. So the first thing we were told to do was factor out the a term, which happens to be a 3. We're going to factor the 3 out of the first two terms only. So if I factor 3 out of 3x squared, I'm going to be left with 1x squared. If I factor 3 out of the negative 6x, I'm going to have a negative 2x. Now, I'm going to say plus some number. We don't know what that number is yet because we haven't done that part. And then we still have plus 4 here minus the a term multiplied by some new number. Now let me explain where that number comes from. What it told you to do, it says take whatever your new b term is after you factored out a. So what we're looking at is this 2 right here. If I take that 2, which happens to be negative, and I divide it by 2, and then square it, that's the number that we're going to get to be placed into where the blanks are right now. So negative 2 divided by positive 2 is negative 1, and negative 1 squared is just 1. So that 1 is what we place into those blank spots, and that's what's going to complete the quadratic expression inside of the first set of parentheses and tells you what you multiply your a value by when we're trying to convert it. Now, let's just continue and see what we get. Inside of the first set of parentheses, we have a quadratic expression that can be factored. In fact, if I factor it, I'm going to get x minus 1 times x minus 1. We still have the plus 4 on the outside, and the negative 3 times positive 1 is just minus 3. Well, let's continue simplifying. 3 times x minus 1 times x minus 1, well, that's just saying, that's the same thing as saying x minus 1 squared. And 4 minus 3 is just 1. And so now we have arrived at the vertex form of the quadratic function that we started with. So while it's in vertex form, we can identify several things. First of all, what is the vertex? The vertex is going to be at positive 1, positive 1. The translations from what we can see in vertex form, we're going to move to the right 1 space. We're going to move up 1 space. That's what the h and k transformations tell you here. Remember, this is h, this is k, this is a. So the a value says that we stretch it vertically by a factor of 3. That means that from what the parent function would look like, imagine taking a rubber band and you pull up on it. It's going to look skinnier than what it did before, and that's kind of what a vertical stretch is going to do to a parabola as well. It's going to look skinnier than what it did before. So let's go ahead and plot the points that we have. We know that the vertex is at positive 1 and positive 1. Now, if you want to, you could try and figure out what some of the roots and stuff are going to be, but if you just remember how to do the transformations from what the parent function is, it's relatively simple to do. The parent function says that from the vertex, when x is 1, y is 1, meaning I go to the right ones and up ones. Well, here, because we're stretching it by a factor of 3, if I go to the right ones, instead of going up 1 time, I'm going to go up 3 times. And it happens to work on both sides because, a parabola works that way. Now, we could continue plotting more points, but if I go to the right 2 times, the parent function says go up 4 times because we have to square everything. Well, if I go to the right 2 times here, and I go up by a factor of 3, well, instead of going up 4 times, I'm really going to go up 12 times. We're not going to really fit on here. So our parabola is really going to kind of go like that. And if you want to, you could look at the discriminant and see, well, there's not going to be any real solutions to this, so that's why it doesn't touch the x-axis at all. And we wind up with something that looks like that. Now here, this is nice to know that we're graphing it correctly. This c term is the same thing as the y-intercept, and you can see that we do touch the y-axis at a positive 4, so we stand a pretty good chance of understanding that, hey, we graphed it correctly. So now let's take a look at our second example. So let me go ahead and write it over here so we can do everything together. So f of x is equal to 2x squared plus 8x plus 3. All right, what we're going to do is we're going to convert this from standard form into vertex form. And again, the first thing it said to do is to factor out the 2, whatever the a term is, from the first two terms of the function. So if I factor out 2 from 2x squared, I just have 1x squared left. If I factor the 2 out from 8x, that'll leave me 4x here. And this is going to be some mystery number that we don't know what it is just yet, minus the a term, plus the c term that we had before, minus the a term, which in this case is 2, times whatever that new mystery number is going to be. Now we don't know what that mystery number is just yet, but what our steps told us to do is once I've factored out the a term, whatever this new term is here, whatever that number is, we're going to take that, divide it by 2, and whatever that quotient is, we square it. And that's what tells us what our new number is going to be that we put into those blanks. So 4 divided by 2 is 2, and 2 squared is 4. So I'm going to put a 4 here and here. And now we can simplify the rest and see what we wind up getting. The whole point of going through this process is right now we have a quadratic expression that can be factored. So I can factor that into, say, x plus 2 times x plus 2 plus 3, and then 2 minus 4 is negative 8. And let's see how we can simplify it further. The whole idea is that we're going to get some quadratic expression that gives us something squared, which is what we see here. X plus 2 times x plus 2 is just x plus 2 squared. And then the 2 minus 8, well, that's minus 5. So here we have our vertex form. So the vertex itself is going to be at negative 2, negative 5, because remember we do the opposite of whatever's in the parentheses. The transformations. The horizontal translation comes from the stuff inside of the parentheses. That x plus 2 really says we go to the left 2 spaces. The minus 5 for the k transformation says we go down 5 spaces, which matches what the vertex is. And then the a term says that we're going to stretch the whole function by a factor of 2. So now let's see what we get. Going to the vertex of negative 2 and negative 5, we're right here. So looking at our transformations, again, from the parent function, we could go to the right ones and up ones from the parent function. Well, because we're stretched by a factor of 2, here I'm going to go to the right ones and up twice. And I'll have the same thing on the left side because parabolas are mirror images of each other. Next, what it said to do is, okay, well, if we touch the, or if we go to the right 2 spaces from the x-axis, or from the origin, I should say, rather the vertex, sorry. If I go 2 spaces from the vertex on the parent function, we would go up 4 spaces. Well, here we have to go up twice as many, so we're going to go up 8 whole spaces. 1, 2, 3, 4, 5, 6, 7, 8. And look, we hit the positive 3, which is what the y-intercept of the standard form tells us it should be. So from here, I can just use my line of symmetry and say we will go 1, 2, my another point should be right there. And so we have plenty of points to go ahead and draw in our parabola. And there is our final graphed function. So now let's take a look at an example where the a term is just 1. See how that affects what we do. So we have x squared minus 6x plus 5. Okay. First thing it says to do is factor out the a term. Well, if I factor out 1, nothing really changes from the first 2 terms. Okay. So what we again look at is what we have inside of these parentheses. In that first set of parentheses, we're looking at the second term, which in this case is a -6. So I'm going to say -6 divided by 2, and I square it and see what I get. Well, -6 divided by 2 is -3. -3 squared is +9. So I put a 9 here and a 9 here. Now, let's continue simplifying it. We have a quadratic expression in the first set of parentheses that can be factored with x minus 3 times x minus 3. And -1 times 9 is -9. So x minus 3 times x minus 3, again, is just x minus 3 squared. And 5 minus 9 is going to give you a -4. So here is our vertex form. So let's identify some key things here. First of all, the vertex. Based on the vertex form, the vertex is going to be at a +3 and a -4. The transformations that occur says it's going to move to the right 3 spaces. It's going to move down 4 spaces. And since the a value is 1, there is no vertical stretching taking place for this one. So those are the only 2 transformations that are occurring. From the parent function, it's going to move 3 spaces to the right and 4 spaces down. So let's go ahead and plot the vertex here and see what we get. Now, from the vertex form and the parent, or from the parent function, if we went to the right once, we would go up once. And since there's no vertical stretching at all, well, we follow the same thing. So line of symmetry says I'm going to have the same thing on the left side. If I go to the right 2 spaces, I will go up 4 whole spaces. And so I'll have the same thing on the left side as well. Now let's try and get one more and see if we can actually see where we touch the y-axis again to see do we actually hit that 5. So if I go to the right 3 spaces, well, 3 squared says I go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I go to the same amount on the left side, well, that hits me right there where the y-intercept says it should be. And now we can just sketch in our parabola. So it's really nice to see that this 5 here and this touching the y-axis here at +5 really does confirm that we're sketching it correctly. And here's going to be our last example where the a term is a fraction, less than 1 but greater than 0. So I'm going to say f of x is equal to 1/2 x squared plus x plus 2. So we're going to go through the exact same process that we have been doing. If I factor out, well, I'm sorry, this is a typo. This actually is supposed to be 3x. My apologies. Let's clean this up just a little bit. So plus 3x plus 2, that's a typo. So let's go ahead and work this out. If you factor out the 1/2 of the first 2 terms, I'm going to be left with 1x squared here. If I factor out 1/2 from 3x's, I'm going to get 6x here, 6x, and then we're going to say plus some new mystery number that we haven't figured out yet. Bring down the c term, the plus 2, and we're going to say minus the a term times whatever that new mystery number is going to be. So let's figure out what that mystery number is. Looking at the middle term of the quadratic in the new set of parentheses on the left, we're going to say 6/2 squared. Well, 6/2 is 3. 3 squared is 9. So here is my new number that I substitute into those parentheses. And let's see what we get. So 1/2, factor the quadratic in the first set of parentheses, and I'm going to get x plus 3 times x plus 3 plus the 2, and then half of 9 is -4.5. You can see where we're going with this one. X plus 3 squared, and 2 minus 4.5 is going to be 2.5. So here is the vertex form. So let's identify our key characteristics. First of all, what is the vertex?
Teachers, just a reminder, on Monday we are doing our faculty and staff photo on the M in the courtyard. Please wear your new polo provided by Mr. Martinez from the start of the year with black or dark colored pants. No jeans, please. Thank you so much. We'll see you Monday.
Well, I'm so sorry about that. I had no idea they were going to interrupt me with an announcement over the intercom. So let's just keep going. The vertex here is going to be -3 and -2.5. The transformations that occur says we're going to go to the left 3 spaces and down 2.5 spaces. And that 1/2 for the A value says that this is not stretched, rather it is compressed by 1/2, meaning that whatever the parent function does vertically, we're now going to only do half of that. So let's identify our vertex, -3 and -2.5. So -3 and 1, 2, and -2.5. Right there's the vertex. So the parent function says if I go to the right once, I go up once. Well, this says do half of that. So if I go to the right once, I go up half a space, which is right there. So I have another one to the left of that. If I go to the right twice, parent function says go up 4 times. Well, that means now I'm only going to go up half that. So go to the right twice, go up 2 times. And same thing here. If I go to the right 3 spaces, parent function says go up 9. Well, now it says only go up 4.5 spaces. So 1, 2, 3, 4.5. And there's my confirmation that we're graphing it correctly, is saying that we're hitting the y-intercept there. And so our parabola will kind of do like that. And it should look wider than the parent function would have been. Okay, now this is pretty much the same process over and over and over and over again. We're going to just take out that a term, factor it out of the first 2, then see what the b value is going to be of that new kind of quadratic expression instead of the first set of parentheses, divide it by 2, square it, and rinse and repeat. And from here, once we have it in vertex form, we can graph it relatively easily based off of the transformations. But hopefully you are up to speed on everything. If you have any questions, please make sure you come see me in class. And thanks for watching, and see you soon.